Okay, so this video is going to go over all the parent functions that you need to know for your next test on Unit 3-2. First thing we're going to do is name each one of these, and after we name them, we're going to graph them. Once we have each graph, we should be able to go answer the questions about domain, range, continuous, discontinuous, what interval is it increasing, what interval is it decreasing, is it symmetric about the y or the origin, and is it even or odd. Okay, so this very first function we have is called an identity function. So this is called the identity. We also, in Algebra 1, called it the linear parent function. So it goes by either name. When you graph this function, we need to have at least 3 points on every one of these graphs. It says for every x value I plug in, it will equal the exact same y value. So 0, 0 is the same, 1, 1 matches, and negative 1, negative 1. Every x has to equal every single y. All right, now that I have a graph, it's really easy to go answer the questions that follow. So they wanted the domain. Remember, your domain goes from left to right. Because this is a function that goes on forever, the domain is all real numbers. One way to write that is using this symbol. Another way we're going to write it is from negative infinity to positive infinity. The range is talking about your y values. It's going down forever and it's going up forever. So again, your range is going to be all real numbers, or you can write it as negative infinity to positive infinity. Both of these mean all real numbers. The next thing it wants to know is this function continuous or discontinuous? There are no asymptotes in this graph, and it goes on forever in both directions. I never have to pick up my pencil as I go from left to right. So we're going to call this a continuous function. They want to know what intervals does this function increase and what intervals does this function decrease. When you're looking at intervals of increase and decrease, you start from the left and move to the right. As I go from left to right, this function continues to go up. So there are no intervals of decrease. I'm only increasing, and that happens from negative infinity to positive infinity. This graph is symmetric to the origin. Remember what that means. It means I do a double flip. I can take this right-hand side of the graph, flip it over the y, and then flip it again over the x, and it'll lie on top of itself. Because it's symmetric to the origin, we're going to call it odd. Okay, second function. This second function right here is called your square function because it's square. In Algebra 1 and Algebra 2, you also called it a quadratic. So I do a graph. So for this graph, again, I need 3 points. So if I plug in 0, 0 squared is 0. If I plug in 1, 1 squared is 1. If I plug in negative 1, negative 1 squared is positive 1. I'm going to go ahead and do one more point on each side. I'm going to go do 2. So 2 squared is 4, so 1, 2, 3, 4. And negative 2 squared is also 4. Quadratics make a U shape called a parabola. And this function goes on forever up. So the domain is going from left to right forever. So again, it's all real numbers, or negative infinity to positive infinity. Our range values, this time my graph doesn't go up and down forever. It only starts at, my lowest y value is 0, and then it goes up. So the way we're going to write this is my range is going to go from 0, bracket means it's included, off to positive infinity. Another way that we sometimes see this is y is greater than equal to 0. On this graph, as I go from left to right to graph these points, there are no asymptotes, and I never have to pick up my pencil or my pen as I graph it. So we're going to call it continuous. Intervals of increase. As I move my pencil from left to right, we'll notice I'm going to go down, I'm going to decrease, and then I'm going to have a turning point at 0, and I'm going to go up, which is my increase. So it goes down, it decreases from negative infinity to 0. 0 is not included because it's a turning point. And then from 0 to positive infinity, it goes back up. This function is symmetric about the y-axis. Because it's symmetric about the y, we call it an even function. The next function we're going to look at, this 1 over x function, is called your reciprocal function. And we're going to do a lot with this later on, but right now we're just going to learn the basic function. So for the reciprocal function, if I plug in 0, 1 divided by 0 is undefined. So at 0, there's an asymptote. If I plug in 1, 1 divided by 1 is 1. If I plug in negative 1, 1 divided by negative 1 is negative 1. So this graph approaches the y-axis and approaches the x-axis from both directions, but it never touches. All right, so let's go do our domain. My domain goes left forever, but not 0, and it goes right forever. The way we write that is it's going to go from negative infinity to 0 and 0 to infinity. Notice there are no brackets here because I'm not including the 0 line. The range is going to follow the exact same thing. It goes up forever and it goes down forever, but it never gets to 0. So it's the exact same thing from negative infinity to 0 and 0 to infinity. When I graph this from left to right, you'll notice I go like this, and then I have to pick up my pencil and do this. So because I have to pick up my pen or my pencil to do the rest of the graph, we're going to call this discontinuous. As I go from left to right, the graph goes down, pick up my pencil, and it continues to go down. So this graph never increases, it only decreases. And it decreases from negative infinity to 0, and then I pick up my pencil, and it's still decreasing from 0 to positive infinity. This graph is symmetric about the origin. Remember, it does the double flip. I can take this part of the graph and flip it over the y, and then flip it over the x. Because it's symmetric to the origin, we're going to call it odd. The next one, 1 over x squared. This is called our reciprocal squared. Okay, let's go look at that graph. If I plug in 0, 1 over 0 squared is undefined. So again, there'll be no point at the 0. If I plug in 1, 1 over 1 squared is 1. So I have a point at 1, 1. If I plug in negative 1, negative 1 squared is a positive 1. Okay, so this one's going to look like this. It's going to approach both axes, but they're both going to be going up. It's kind of like a volcano. I usually call the reciprocal square the one that looks like the volcano. Let's go do our domain again. Again, as I go from left to right, I'm using every single x but not 0, and then every single x to the right. So it's going to look just like the one we did before, from negative infinity to 0 and 0 to infinity. My range is not everything, because there's nothing down here at the bottom. My range is only the values of y that are greater than 0. So it's from 0 off to infinity. Remember, we can also write this like this if we want. As I go from left to right, I have to pick up my pencil to finish the graph. Because you have to pick up your pencil or your pen, we're going to call it discontinuous. As I go from left to right, my function increases, and then my function decreases. So it increases on the left side of the graph from negative infinity to 0, but then on the right side of the graph it goes down, so it's going to decrease from 0 to positive infinity. This graph is symmetric to the y-axis. Because it's symmetric to the y, we're going to call it an even graph. The next function we're going to look at is called your absolute value function. Let's go to our graph. Remember, absolute value means your distance from 0. So if I go plug in 0, 0, the absolute value of 0 is 0. If I go plug in 1, the absolute value of 1 is 1. If I go plug in -1, the absolute value of -1 is still 1. I'm going to go do one more point on each side. -2, the absolute value, and +2, the absolute value, are both 2. So it looks really similar to your square, except one thing is that these are straight lines, not curves. This has 1, 1, and 2, 2. This one over here has 1, 1, and 2, 4. So be very careful when you're looking at these functions. Okay, so the domain, it goes forever to the left, it goes forever to the right, and this time 0 is included, so we're -infinity to +infinity, or all real numbers, either way. You'll notice that my graph is not using all the y values, it's only using the y values including 0 and above. So we're going to say bracket 0 off to infinity, or y is greater than or equal to 0. Both of those are okay. As I go from the left to the right, I never have to pick up my pen or pencil. So we're going to call it continuous. As I go from the left to the right, the first thing I notice is on the left side of the graph, it's decreasing, and on the right side of the graph, I'm increasing. So I'm decreasing from -infinity to 0, but I'm increasing from 0 to infinity. This is a metric about the y-axis, therefore it's called even. Okay, let's go look at this next function. This is my square root function. Okay, so let's go do our graph of the square root function. If I go plug in 0, the square root of 0 is 0. The square root of 1 is 1. The square root of 2, the square root of 3, neither one of those are perfect squares. But the square root of 4 is 2. So I have a point at 0, 0, 1, 1, and 4, 2. It goes on forever to the right. So on this graph, notice I'm not using any x values over here to the left, only to the right. So my domain is 0 off to infinity, or x is greater than or equal to 0. My range values are only above the 0 line, so my range values are 0 to infinity, or again, because it's range, y is greater than or equal to 0. As I go from left to right, and I will look at this curve of the function, I never have to pick up my pen or pencil, so we're going to call it continuous. As I go from left to right, I'm only increasing, so there is no decrease, and I'm increasing from 0 to infinity. That's a turning point, so that's actually a parentheses, not a bracket. This is not symmetric to the y, and it's not symmetric to the origin. So this is a none. Because it's a none, it's also neither even or odd. The last one we have on the front of this worksheet is called your cube root function. So we're going to go do our graph the same way that we have been. The cube root of 0 is 0. The cube root of 1 is 1. 2 doesn't have a cube root. 3 doesn't have a cube root. In fact, you don't get to another one until you get to 8. So 2, 3, 4, 5, 6, 7, 8. And the cube root of 8 is 3. So it goes like this. I can take cube roots of negative. So the cube root of -1 is -1. And then it goes all the way until you get to -8. So this is what your cube root looks like. The domain goes on forever, left and right. So it's a -infinity to +infinity, which again is all real numbers. Your range, even though it's going up very slowly, it goes up very slowly forever and down very slowly forever. So again, it's the same thing. I never pick up my pencil as I go from left to right. So we're going to call it continuous. As I go from the left to the right, my function is continually increasing. So there is no decreasing. And it's increasing from -infinity to +infinity. This is symmetric about the origin because I can do a double flip. Because it's symmetric to the origin, we're going to call it odd. Okay, so far all we've done is gone over the front of the worksheet. We did our identity, our square, our reciprocal, reciprocal squared, absolute value, square root, and cube root. So now let's go look at the back of the worksheet. And let's go over these. So on the back of the worksheet, the first one we get to is called my log function. Logarithmic, but we're just going to call it log for short. You learned about these a little bit in Algebra 2. Let's go look at the graph of this. For this particular graph, when you have a log function, it's always going to touch the x at 1, 0. It's going to go up, and then it's going to approach the y, but never really get to it. So it looks like this. So that's my log function. So it doesn't go forever both ways. It only goes forever to the right, and it never really touches 0. It just gets really close. So your domain is going to go from 0 off to infinity. Now notice your range. It does go down forever, and it does go up forever. So your range is going to be from negative infinity to positive infinity. Again, all real numbers. As I go from left to right, I never pick up my pencil. As I go from left to right, I'm only increasing. There is no decrease. So we're increasing from 0 to infinity. It's not symmetric to the y or the origin, so this is a none. Because this is none, it's neither even or odd. Our next function is called our exponential function. For its graph, it's going to touch the y at 1, and it's going to go up, and then it's going to approach the x but never touch. So these are the opposite. Notice the exponential touches the y at 1, the log touches the x at 1. The exponential approaches the x but never touches it. The log approaches the y but never touches it. So if you know one, you know the other. They're just the opposite. So as I look at my domain, it's going to go from negative infinity to infinity. Notice that they're the opposite. My range is going to always be above the x-axis, so it's going to be above 0, but it's never going to get there. Again, these are just the opposites. As I go from left to right, we don't have to pick up our pencil, so we're going to call it discontinuous. As I go from left to right, I'm sorry, I wrote that wrong. Try that again. As I go from left to right, I don't pick up my pencil, so it is continuous. You're probably wondering what was wrong with me. Okay. As I go from left to right, I only increase. So I'm increasing from negative infinity to positive infinity. There's still no symmetry, so it's still neither even or odd. Okay. The next one we're going to call our cube function. So we're going to go plug in values again. 0 to the third power is 0. 1 to the third power is 1. 2 to the third power is 8. So 1, 2, 3, 4, 5, 6, 7, 8. So it'll be way up here. Negative 1 to the third power is negative 1. And negative 2 to the third power would be negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. So this is what your cube function looks like. So our domain, it goes to the left forever, very slowly. It goes to the right forever, very slowly. But we're still going forever in both directions. Your y values also go up and down forever. So same thing. Negative infinity to positive infinity, and all real numbers. As I go from left to right, I'm never picking up my pencil, so we're going to call it continuous. As I go from left to right, I'm only going up, so it's only increasing. It never decreases. This function, if I flip it over the y and then flip it again over the x, it's symmetric about the origin. Because it's symmetric to the origin, we're going to call it odd. Okay, these last three functions that we have to take care of, sine, cosine, and tangent, are our trig functions. And we've done these this year, so these should be easy for you, at least I hope they are. This first one we're going to look at is our sine function. Remember, this is not sin, it's sine. And when we graph sine, we learned how to graph it between positive 2 pi and negative 2 pi. And we always went up to 1 and down to negative 1. And then we're going to half it, half it, half it. And we did a lot of this year. So sine, Ms. Puckett used to call it the original sin, which means it starts at the origin. And then my pattern was the origin, the max, the axis, the minimum, the axis. Okay, and we're just going to keep that pattern going the opposite way. So I'm going to go minimum, axis, max, axis. Okay, so this is our sine function. The domain for sine goes on forever in both directions. So negative infinity to positive infinity. Now my range doesn't go on forever because it stops at 1 and stops at negative 1. So bracket because it's included, bracket because it's included. I never have to pick up my pencil, so it's continuous. All right, so for these three last functions that we're going to do, we're not going to do intervals of increase or decrease. Instead, what we're going to write in here is we're going to write our fundamental periods. So we're changing these last three. And we're going to write the fundamental period. And that just means how long it takes to make one complete cycle. So one complete cycle of axis max, axis minimum, axis takes 2 pi's. This is symmetric to the origin. So it is odd. The next trig function we talked about is not called cos, it's called cosine. We're going to graph it on the same type of graph from negative 2 pi to positive 2 pi. It also goes up to 1 and down to negative 1. And we half it, half it, half it. Cosine does not start at the origin. Cosine starts at the max. So it goes max, axis, minimum, axis, max. So this is the right side. And then it just repeats the pattern. It goes back to the axis, the minimum, the axis, and the max. This is the one that looks like the W. So the domain is the same. It's still going to go on forever. The range is still being capped out between 1 and negative 1. It's still continuous. My pattern for cosine is max, axis, minimum, axis, max. That takes it takes a complete 2 pi's to make a cycle. So your fundamental period is called 2 pi. This is symmetric about the y-axis. That means it's even. And the last trig function that we did is called tangent. Now for tangent, I'm just going to graph the right side, only because I'm getting lazy. Okay, so here's my pi, here's my 2 pi, half it, half it. So for tangent, it starts at the origin, and it goes up on the right, asymptote. It goes to pi, it goes up on the right, down on the left, asymptote. So this is the pattern that continues. It only takes 1 pi in order to do this cycle, so we're going to call the fundamental period pi. The domain does not go on forever because I keep having asymptotes, and all my asymptotes are all the pi over 2. So pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2. So the way that we learned to write this before was x cannot equal any multiples of pi over 2, where n is an element of an integer, just meaning for anything that you have pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and the opposite way, those are what x's cannot be. That's where my asymptotes are. It goes up forever and down forever. So my range this time is going to go from negative infinity to positive infinity, or all real numbers. As I go from the left to right, I have to pick up my pencil because I have these asymptotes. So it's discontinuous. This is symmetric about the origin if I were to go to the other half of this graph. Because it's symmetric about the origin, we're going to call it odd. All right, guys, you're going to need to study all of these functions. So we just went over the log function, the exponential, the cube, and then my 3 trig functions that we already covered this year. You need to know all of these for your next test. Good luck.